Morning, dear children. Today we are going to study the chapter Application of Trigonometry. Application of Trigonometry is the continuation of the chapter Introduction to Trigonometry, which we already completed. All the concepts you studied in that chapter must be there in your mind for the better understanding of the chapter Application of Trigonometry. And we have to study two main concepts in the chapter, that is angle of elevation and angle of depression. What is angle of elevation? See, angle of elevation is the angle between a horizontal line from the observer and the line of sight to an object that is above the horizontal line. There are two things mentioned here, horizontal line and line of sight to an object. What is horizontal line? See the figure. The straight sight from the eye of an observer is horizontal line. The horizontal line is always parallel to the ground. Horizontal line is the straight sight, straight view, straight line from the eye of an observer. Means if an observer is looking straight, horizontal line forms. That is a normal vision. And for a line of sight means if you want to see an object, if you want to view an object, we have to move the direction of our eye towards the object. That is called a line of sight. See, this is a horizontal line, and if the above object is above the horizontal line, in this case the object is marked above the horizontal line. If the object is above the horizontal line and this is the observer, observer has to look up. This is the normal horizontal line. When the observer looks up, this is the line of sight to see the object. He looks up to see this object. Now this line is formed. This is the first line, horizontal line, and this is line of sight to see the object. Then angle between horizontal line and line of sight is formed here. That is called a angle of elevation. So angle of elevation is the angle between horizontal line and line of sight if the object is above the horizontal line. Same way we can define angle of depression also. In the case of angle of elevation is above the horizontal line, and in the case of angle of depression, object is below the horizontal line. Here is the observer, and to see an object below the horizontal line, the observer has to look down. So this is the line of sight from his eye to see the object, and this is a normal horizontal line. So the angle between horizontal line and line of sight to the object is called the angle of depression. So remember, angle of elevation occur if the object is above the horizontal line, or if we see the object, if we look the object above the horizontal line, and angle of depression is formed if we look the object below the horizontal line. And elevation is the angle between horizontal line and line of sight if the object is above the horizontal line. And angle of depression is the angle between horizontal line and line of sight if the object is below the horizontal line. Means both the angles, angle of elevation and angle of depression, are formed by horizontal line and line of sight. The only difference is elevation occur if the object is above the horizontal line, and depression forms if the object is below the horizontal line. Okay. This is another example of angle of elevation. Here you can see horizontal line is marked over here. This is horizontal line. This aeroplane is above the horizontal line, so angle of elevation is formed. Person is looking up to see the object. So the angle between horizontal line and line of sight. See the animal here. To see the animal here, the person looks down. This is the line of sight. So angle between horizontal line and this line of sight is angle of depression in this figure. Here also you see a person is standing on the lighthouse. Horizontal line is a straight sight from his eye. This is the horizontal line from his eye, and this is the line of sight to see the person standing here. So this is the angle of depression. Similarly, in the case of this example, here angle of elevation is formed from the ground. Angle of here observer, the case of observer is not mentioned. Elevation to the top of the tree from the ground, that is angle of elevation. Now let's discuss some examples. examples of text exercise questions of textbook. I think the concept, elevation and depression are clear. Let us go to the examples in the textbook. I'm very sorry, exercise questions in the textbook. Question number 1 in the textbook is: a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. It's an important question. In this type of questions, the first thing that we want to do is read the question very carefully and draw the figure corresponding to the question. Drawing or construction of the figure is very important in this type of question. The word problem must be converted into a figure. See, the circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. So first let us draw the ground. This is BC is the ground, and a pole is fixed on the ground. And what is the circus artist doing? And a rope is tied to this. AB is the pole, means A is the top of the pole and B is the foot of the pole. Top means upper part and the foot is bottom part where it is fixed to the ground. And a rope is tied to the top of the pole. And how the rope is tied? It is tightly stretched and tied from a vertical pole to the ground. It is tight. This is the rope. This green color represents the rope. It is not loose. It is tightly stretched and tied to a point on the ground. Okay. So if it is so, and when the rope is tightly stretched and tied to the ground, an angle will be formed over there. Then the angle formed by the ground level and the rope is 30 degree. If it is so, we have to find the length of the rope. Here we are given we are given the length of the rope. We have to find the height of the pole. We have to find this height. And listen very carefully. We have to find the length of AB, length of the pole, and we know the length of AC. And consider this right triangle ABC. And if we consider AB and AC with respect to angle 30, or for angle 30, this AB is the opposite side and AC is the hypotenuse. So we are given hypotenuse and we have to find the opposite side of 30 degree. And for 30 degree, the relation connecting opposite side and hypotenuse is sine of angle 30. So there are 6 ratios: sine, cos, tan, cosec, sec, cot, and we have to select a better ratio or a suitable ratio for finding the height of the pole. And how can we select that ratio? We have to think. We have to find the opposite side of 30 degree in this right triangle, and we know the hypotenuse. And which one is asked to find and which one is given? Opposite side we have to find and hypotenuse is given. And the relation connecting opposite side and hypotenuse is sine ratio. So here the angle is 30. So we have to take the ratio sine 30. So sine 30 is equal to, here in this figure, AB by AC. And we know the value sine 30 is 1 by 2, which is AB by AC is also given here as 20. Cross multiplying, 20 equal to 2AB, where we will get AB equal to 20 by 2, and the answer is 10 meter. So height of the pole equal to 10 meter. See the next question. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. See, there is a tree fixed on the ground. The total length of the tree is this AB. Okay. Due to storm, because of the storm, what happens to the tree? The tree breaks. Normally, when the tree breaks, it will fall down. And when the tree fell, suppose the tree breaks from the point C. I marked the point from where the tree breaks. And from the point C, the tree breaks and this upper part falls down. See the second figure. Here it fell down. Okay. When the tree falls down, it touches the ground. And where it touches the ground, which is 8 meter away from the foot of the tree. In this case, A is the top of the tree, B is the foot of the tree. And when the tree breaks and falls down, here is the foot of the tree, the top of the tree touches the ground, which is 8 meter away from the foot of the tree. And when the tree falls down and when the top touches the ground, it makes 30° with the ground. Okay, it makes 30° with the ground. If it is so, we are asked to find the height of the tree. I told you height of the tree is this one, total height. If we split it, it is AC plus CB. And here AC is straight on the ground, perpendicular on the ground, and CB is fallen down. It is now in the slanting position, it fall down. So for finding the total height of the tree, we have to add AC and BC. In this figure, this AC and BC we have to find. So total height of the tree here is AB, which is AC plus BC. When we convert it to this figure, when the tree falls down, total height becomes AC plus BC in this figure also. And here BC is total height of the tree. To find BC, suppose we are going to find BC. Remember, in this right triangle, now we have got a right triangle over here. Right triangle, the angle is 30°. And we have to find BC and AC. First, if we are going to find BC, let us think very carefully that for 30°, we have to find the opposite side and we are given the adjacent side. For finding BC, BC is the opposite side, and for finding the opposite side of angle 30, we know the adjacent side. And relation connecting opposite side and adjacent side is tan ratio. So we have to take tan 30. Why we selected tan 30 without selecting sine and cos? Here we have to find opposite side of 30° and we are given adjacent side of 30°. And the relation connecting opposite side and adjacent side is tan. So tan 30 is selected. So tan 30 is opposite side BC by adjacent side AB. So the value of, here it is, value of tan 30 is 1 by root 3. BC we have to find and AB we know. Tan 30 is BC by BA. Okay, not AC. BC by BA. Tan 30 is BC is already BC. We have to find. And BA is 8 meter. So 1 by root 3 equal to BC by 8. Cross multiplying BC root 3 equal to 8. Where BC equal to 8 by root 3. Similarly for finding AC. Suppose we got this side also. So we can use Pythagoras theorem also. But it is very easy to find using the trigonometric ratios. See, we have to find AC and we know AB. So the relation connect AB is the adjacent side of 30° and AC is the hypotenuse of hypotenuse. So the relation connecting adjacent side and hypotenuse is cos ratio. So we have selected cos 30. Cos 30 is BA by AC. Cos 30 value is root 3. So root 3 by 2 is equal to AB is 8 and AC is AC only. Cross multiplying root 3 AC equal to 8 into 2 and here that implies AC equal to 8 into 2 is 16 by root 3. So that is, now we got the AC also. First we got the length of BC as 8 by root 3 and now length of AC as 16 by root 3. And what is the total height of the tree? It is BC plus AC. So that is equal to BC plus A is 8 by root 3 plus 16 by root 3. On simplifying, 24 by root 3 and 25 by root 3 is the answer, but root 3 is an irrational number. So rationalizing 24 into root 3 divided by root 3 into root 3. So 24 root 3 by 3 which is equal to 8 root 3. So if you want, you can substitute the value of 1.73. 1.73 is the value of root 3. You can substitute it and simplify with it, or you can just keep it as 8 root 3. Okay, that's all. And the next question is, a contractor plans to install two slides for the children to play in a park. For the children below 5 years, she preferred to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas for elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree with the ground. What should be the length of the slide in each case? Here, this is the first slide, this is the second slide and this is for the children below 5 years and this for elder children. Sorry. Here we have to find this length. This is the slide. Children will be climbing over here and sliding this side. Here also children will climb step by step up and they will be sliding down. And in both cases, we have to find the length of AC. Take the first figure. In the first figure, the height of the slide is 1.5 meter. Sorry. Height of the slide is 1.5 meter and angle the slide makes with the ground is 30 degree. And we have to find the length, this length of the slide. Means for angle 30 degree or of angle 30 degree, we are given the opposite side and we have to find hypotenuse. Here 30 degree, opposite side is given, hypotenuse to find. So the relation connecting opposite side and hypotenuse is sine ratio, and in this case sine ratio of 30 degree. So sine 30 equal to AB by AC. Sine 30 is 1 by 2 equal to AB is 1.5 by AC. Cross multiplying, AC equal to 1.5 into 2, which is equal to 3 meter. So length of this slide is 3 meter. The same procedure is to find the height length of the second slide. Here the angle of elevation inclined at an angle of 60 degree. This angle is 60 degree. So for angle 60 degree, we are given the opposite side and we have to find hypotenuse. So the relation connecting opposite side and hypotenuse, sine ratio, sine 30, which is AB by AC, sorry, sine 60, I'm very sorry, sine 60, here 60 degree is the angle. Sine 60 is AB by AC, sine 60 is root 3 by 2, AB is 3 by AC, cross multiplying root 3 AC equal to, cross multiplying here 3 into 2, so AC equal to 3 into 2 by root 3. So rationalizing, it will be 2 root 3. You can write it as 6 by root 3 and rationalize it. Or here what I have done is I have split it 3 as root 3 into root 3 into 2 by root 3 and 1 root 3 is cancelled. I did not write it as 6 by root 3. Here 3 is 3. Here 3 is written as, this 3 is written as root 3 into root 3. Okay. And that's equal to, so 1 root 3 is cancelled. So remaining 2 in the numerator, 2 into root 3. Means 2 into 1.73 to 3.46. So length of the second slide is 3.46. Okay. Next question. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. Draw the figure corresponding to the question. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower. Let us consider this as the tower. AB is the tower. Let AB is the tower. An angle of elevation is made to the top of the tower. Someone is looking or from the ground, elevation to the top, the slide, the slanting, the elevation while looking at the top of the tower like this is 30 degree. Okay. If from this point angle of elevation, from this point the top is observed. So this point of observation is 30 meter away from the foot of the tower. Okay, foot of the tower is B. From B, the point of observation is 30 meter away. If it is so, what is the height of the tower? That's the question. So here the angle is 30 degree, and for the angle 30 degree in right triangle ABC, for angle 30 degree, the adjacent side is given as 30 meter and we have to find the opposite side. All the questions must be converted into figure, and the figure must be understood clearly. And here for 30 degree adjacent side is known, and we have to find the opposite side. And the relation connecting adjacent side and opposite side of 30 degree is tan 30, and in this figure tan 30 equal to AB by BC. Tan 30 value is 1 by root 3 is AB by BC is given as 30. Cross multiplying root 3 AB equal to 30, AB equal to 30 by root 3, rationalizing, multiply numerator denominator by 30, sorry root 3, so 30 into root 3 by root 3 into root 3, so 30 root 3, 1 root 3 is cancelled over here, so I'm very sorry, not like that, 30 into root 3 by, we are rationalizing root 3 into root 3, so it gets 30 into root 3 by 3, so 3 is cancelling, so it is 10 root 3, 10 into 1.732, 17.32. Next one, a kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. What is it? A kite is flying over here, and the height at which the kite is flying is 60 meter. When the kite flies, here is the string of the kite, here is the string, and the kite is flying like this. When the kite is flying, it is at the height of 60 meter from the ground. Okay, and if it is the string is not loose, the string is tightly stretched. This is the string is tight, and it is tied to a point on the ground. Okay, assuming that there is no slack in the string, it is when we fix the kite, the string of the kite on the ground, that kite will try to fly in the maximum height. So certainly there won't be any slack in the string. It will be like a straight line. If you have the experience of playing with the kite, you will experience it. So if you fix it, if it is in our hand also, if the strong wind comes, the line of the string of the kite becomes like a straight line. So same thing happen here. It is fixed to the point on the ground. This is a string, and find the length of the string assuming that there is no slack in the string, and the height of the kite from the ground and length of the string and the ground level together makes a right triangle. So in this right triangle, you see the string and the ground. When the string is attached to the point on the ground, an angle of 30 degree is formed. 60 degree, I'm very sorry, angle of 60 degree is formed. Okay, so for 60 degree it is the opposite side, and here in this triangle it is the hypotenuse. Means with respect to 60 degree we are given the opposite side and we have to find the hypotenuse. And the relation connecting opposite side and hypotenuse is sine ratio, and here in this problem, in this question or in this triangle, this is 60 degree, so we have to select a sine 60 degree. Sine 60 degree equal to AB by AC. So sine 60 is root 3 by 2, AB is 60 by AC. So root 3 by 2 equal to 60 by AC, cross multiplying root 3 AC equal to 60 into 2. So AC equal to 60 into 2 by root 3, 120 by root 3 we will get. And for rationalizing, multiply numerator and denominator by root 3. So 120 into root 3 by root 3 into root 3. So 120 into root 3 by 3. So it is 40 root 3. Okay. Next one is a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eye to the top of the building increases from 30 to 60 degree as he walks towards the building. Find the distance he walked towards the building. So what is mentioned in the question? This is the here is the ground level, and a 1.5 meter boy suppose is standing here, and this is the building. AB, you can see AB is the building. The length of the height of the building is 30 meter. Ground, here the building, and the boy is standing here. What the boy is doing? Now he is standing here and he looks the top of the building. This is the line of sight from his eye. A line of sight from his eye is marked here, and certainly the point, this top of the building is above the horizon. This is the horizontal line here, ground level, and parallel to this horizontal line we have to draw the horizontal line here from the eye of the boy. Then only we can mark this angle. Okay, so this is the line of sight to see the top of the building. This is the horizontal line. Angle between horizontal line and line of sight to see the top of the building is 30 degree. Now, and what he does, now the position of the boy is here. He walks towards the building, and now he reached here, and from here again he looks the top of the building. Okay, this is the horizontal line. This is the line of sight to the top of the building. In the second case, when he looks up to the top of the building, angle of elevation becomes 60 degree. And when he walks towards the building, normally angle of elevation will be increasing. Okay, and we are asked to find the distance walked by him towards the building. At first he was here. The next case he was here. The distance walked by the boy is this one. So we have to find the length CD. And geometrically we can say CD equal to this total length CE minus DE. What is this length? Total length minus this length. We will get a CD. And for finding that, so first we have to find a DE. For finding DE, we have to consider the small right triangle, and DE is the side of the small right triangle. So in this red colored right triangle, we have to find a DE. DE is the adjacent side of 60 degree. And can we find the length of AE? Height of the building is 30 meter, and the height of the boy, this one, is 1.5. So 30 minus 1.5, so this height will be 28.5. So adjacent side of 60 degree is DE and opposite side of 60 degree is 28.5. Taking that, so since we have to find DE, we have to find a relation connecting opposite side and adjacent side. Opposite side and adjacent side relation is tan. So tan of 60 degrees AE by DE. Tan 60 we know root 3. AE is 28.5 by DE. Cross multiplying, root 3 DE equal to 28.5, whereas DE equal to 28.5 by root 3. What we can do here is either we can stop it here, or here itself we can rationalize the denominator root 3, or we can rationalize it at the end of the answer. Now we found DE. What we have to find now? Next we have to find a CE. To find CE, CE is a part of this right triangle. CE is a part of this right triangle AEC, and the angle in that right triangle is 30 degree. So, and in this right triangle, 30 degrees here, we have to find CE. CE means adjacent side of the 30 degree, and we have to we are given the opposite side. We have to find the adjacent side CE. The same relation is tan of 30 degree. Tan 30 is AE by CE. Tan 30 is 1 by root 3. So 28.5 by CE. So CE is equal to 28.5 root 3. So we got CE also. And we have to find CD, this length. CD is CE minus DE. 28.5 root 3 minus 28.5 by root 3. This length. That is DE. Okay. And how to simplify that, you see. Here it is 28.5 into root 3 minus 28.5 divided by root 3. Cross multiplying, 28.5 root 3 into root 3 minus 28.5 whole divided by root 3. And 28.5 into root 3 into root 3 is 3 minus 28.5. In the numerator, two terms, 28.5 into root 3 minus 28.5. In both cases, 28.5 is common. Taking 28 point outside, we will get 28.5 into 3 minus 1 divided by root 3. So 28.5 into 3 minus 1 is 2. 28.5 into 2 is 57. So 57 by root 3, rationalizing 57 by root 3 into root 3, numerator also into root 3. So 57 root 3 by 3, 57 by 3 is 19, 19 root 3. So 19 into 1.732, 32.908. We can round it to 33 approximately. So that's the distance walked by the boy, 33 meter approximately. And next question, from a point on the ground, the angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building are 45 and 60 degree respectively. Find the height of the tower. Here you see, from a point on the ground, this is the ground. This is the ground. Angle of elevation of the top and bottom of a transmission tower fixed at the top of a 20-meter high building. 20-meter high building is here. On the building, top of the building, a transmission tower is fixed. So we can say AB is the transmission tower which is placed upon the building BC, and it is on the ground. And what happens then? The angle, so AB is the transmission tower, right? So A is the top of the transmission tower, B is the foot of the transmission tower. At the same time, B is the top of the building and C is the foot of the building. That means foot of the transmission tower and top of the building are same. That is B. Okay. And what is our angle? And from a point on the ground, this is a point on the ground. From a point on the ground, angles of elevation of the bottom and top of a transmission tower. Bottom. Transmission tower is here. B is the bottom of the transmission tower. A is the top of the transmission tower. Angle of elevation to the bottom and top are 45 and 60 degree respectively. That means from here, angle of elevation to the bottom is 45 degree and angle of elevation to the top of the tower is 60 degree. Figure is like that. Then you are asked to find the height of the transmission tower. In this figure, we can say, as in the previous problem, we have to find AB. So geometrically, AB equal to this total AC minus BC. Okay. So first let us find BC. To find BC, we have to consider this right angle at C. And in this right triangle, angle is 45 degree, right? For 45 degree, we are given this BC. We are given BC, and if we are about to find a DC, it will be the relation connecting opposite side and adjacent side is tan 45 BC by DC. Tan 45 is 1, BC is 20, 20 by DC, so DC equal to cross multiplying 20 itself. And in the bigger right triangle, and to find AC, we have to depend upon AC. Here actually, not to find BC, we have to find a DC here, children. By mistake I wrote to find BC. BC is already given here. We have to find a DC. Correct it. Okay. And in the second case, if this is 60 degree angle, we have to consider the right triangle ACD. This triangle ACD. This is right angle. In this case, we found the adjacent side of 60 degree we got now, which is DC. Just now we found out at 20 meter. And with respect to angle 60 degree, the relation connecting adjacent side and opposite side is tan itself. Tan 60 equal to the total length AC by DC. So tan 60 is root 3. AC can be splitted as AB plus BC. Here AB plus BC. AB plus BC by DC. Okay. So root 3 equal to AB plus BC we know is 20 by DC. Just now we found out DC equal to 20. So cross multiplying 20 root 3 equal to AB plus 20 and transposing constant to the same side. 20 root 3 minus 20 equal to AB. So here 20 root 3 minus 20. 20 is common factor, taking it outside. 20 into root 3 minus 1 equal to AB. 20 into root 3 means 1.73 minus 1. Okay, equal to which is equal to AB equal to 20 into 1.73 minus 1, which is equal to 20 into 1.73 minus 1 is 0.73. So 20 into 0.73 is same as 2 into 7.3, which is 14.6 meter. That is the next question. So the remaining questions will be explained in the next video. Thank you.